So I'm recording now. I hope it will work. And it will be available on YouTube, I think. So today we will go through anonymous communication protocols and authentication systems. Yep. So I know that you are also researching on anonymous communication protocols, yeah? Some messengers or something. So I think it will be interesting to you. And yeah, let's start. So what do we need for anonymity, like in internet or in communication protocols? What do you think? Why do we need? Sorry.
For honesty, probably. For example, somebody may be scared of telling the truth, and anonymity can provide the truth. Like if nobody knows, you can say anything without the circumstances.
So it's kind of deceiving someone, or like?
I don't know. Like let's say job condition, like in the company, and if they have an anonymous, like totally anonymous survey or something,
Yeah.
they will have better feedback. Like nobody is afraid of any manager or like director or something. They will tell the truth, what they feel, and they at the same time.
Yeah, I agree. In this specific case, yeah, sure. But if we think more broadly, like just like browsing in internet, do we need anonymity in that case? Like just searching for websites and reading some articles and something like that. So, yeah.
People generally want like a base level of privacy.
Yeah. So you think, yeah. So yeah, some people want to hide their identity, some of their personal identity information, and yeah, or as you told, like they want to hide something from their employer or some specific person, and yeah, so it's sometimes it might not be safe to use internet, like specifically in restaurants, in some public places, if you connect to Wi-Fi there, so there is some risk. Yeah.
And how about the bus and trains? Is it safe? Like I usually use it.
Yeah, probably because it's more like government. It's controlled by government, and it has like passwords and so on usually.
It doesn't have like the open free internet. I always like connect.
Yeah, sure. But I think it's like still controlled by government,
Yeah.
so it's somehow safe, but much risky than your private internet connection. Yeah.
It's like free.
Yeah, it's open, so yeah. So I asked you to read about Tor. Did you do some homework on that? Probably. So I will go through about the project briefly. So the project was initiated in 1995 by US Naval Research Laboratories, and the main goal was to design an anonymous communication network for military communication. But then they decided to make it public, and why do you think why they have done that choice? Yeah.
Because if they didn't make it public, then any time this, like the one that we're trying to connect to saw information coming from Tor, they would know it was military using it. But if it was available publicly, then they didn't know if it was military or just some random guy who wanted a bit more privacy.
Yeah, right. So when they made it public, like it spread worldwide. So currently it had like more than 6,000 nodes worldwide. So and still this military, I mean the U.S. forces use it still, and they can hide their identity and so on. Like, and currently it has 2.5 million active Tor users. Yeah. So I think they reached their goal. And so what kind of advantages using Tor gives. So it preserves kind of your privacy. IP addresses address isn't revealed, and it makes, like, as it uses encryption, it's more safe and secure. And also, if you use Tor browser, it will not store any information about your. It will not track you, basically. Yeah, so it's more. You can fight against browser fingerprinting. So the network itself is works like in this picture in the left. So it has many routers, or they call it relays, and it passes. First, you need to choose 3 routers by which you direct your traffic. So and you have to encrypt it 3 times, as shown in the right figure. So a message will be encrypted 3 times with each key, and as it passes the network, it will be decrypted 3 times. And at the last stage, as you can see, yeah, so this connection after the last node, it isn't encrypted, basically. So it will be sent without encryption. But in some cases, if it uses HTTP, it could be encrypted, yeah. But otherwise, it isn't encrypted. And so how it works? So basically, Tor uses as a key exchange, they use symmetric key encryption, advanced encryption standard. So first, they make a handshake with nodes and send their exchange their keys, and after that, nodes can encrypt the message when they receive it. So, but what are the weaknesses of Tor? Do you have any ideas? Yeah. Even though this network gives you some kind of anonymity, but still it has some weaknesses.
Probably it's slow.
Yeah, you are right. So it gives you some like low performance because it have to choose a route and encryption. Yeah, and that takes time. I mean, kinda. So it's more. It isn't suitable for real-time communication, probably. Yeah. Anything else? As you may notice, the last part isn't encrypted. So it could be used for traffic analysis and so on, because it isn't encrypted still. So yeah, exit nodes can be hacked, thereby exposing users' data, and performance will suffer, resulting in low speed. And some attacks could be like for analyzing the traffic. The second protocol is Whisper. It's a new protocol compared to Tor. So it's a peer-to-peer communication protocol for dApps, distributed applications. Do you know what is dApps, or anyone? Yeah.
Yeah, it's just another name for distributed applications.
Yeah.
Typically running on some kind of blockchain.
Yeah, you're right. Yeah, so it's like dApps are using like distributed computing network. So yeah, like blockchain, like Ethereum, smart contracts, and so on. And so it's also designed to deliver darkness as Tor. It's here it says total anonymity, but yeah, you can. There could be like some leaks, of course. It isn't ideal. At high cost, what high cost means? High cost means high network bandwidth usage and high computational power. So it requires high cost. And it's part of Ethereum ecosystem. So when you download Ethereum tools, you'll also download this Whisper for communication as a messaging protocol. And there is a trade-off between level of privacy desired and performance, as in Tor. So yeah. What is darkness here? So darkness means there is no meta information is leaked, and there is plausible deniability. So if a particular message is found on a machine, it cannot be proved that the message was addressed to you, specifically to you. And yeah, let's see how it works. So the basic principle is the main difference between Tor and Whisper is like here message will be delivered to every node. So by that way it hides the recipient basically, because it delivers the message to all nodes. And in that way you cannot be sure that who is the recipient. So node broadcasts the message to its neighboring nodes, but only recipient has a key to decrypt it. So it will be delivered to every node, but only recipient will have the decryption key. And all nodes continuously forward the message to nearby nodes. So it's like a blockchain, yeah. So it just delivers and spreads the message. Yeah.
Is it really working browser Whisper? Like it's currently in use, like people are using it?
It isn't browser basically. It's like messaging protocol, and it's used as a part of Ethereum.
Yeah.
Yeah, it's used, but it's like how to say proof of concept. So like it's still developing.
Yeah.
And I think like just regular users without technical knowledge, without knowledge of blockchain, probably will not be able to use it. Yeah.
Yeah. Probably I will need also hardware or video card to use it, right?
Yeah.
Because I need to add my computation power. Then
yeah, sure. Okay. You should be like an act as a node. So yeah.
Like a miner, right?
Yeah, kind of small miner. So it's like it's I think one of limitations for wider adoption of this messenger. But we want to just see how they implemented it, yeah, like so technically. So even the recipient, after he receives it, it forwards it to another node. So like to make it untraceable. So, yeah. So the message structure is like contains time to live, time to live, and so yeah, so it's and there is a topic which is used for filtering when decrypting. I will talk about more about topic here, and there is nonce. It's a random number for proof of work to prevent spamming. So every node can do some proof of work, as he told, like it needs to perform some proof of work to send the message, basically. And so it prevents spamming, because if you don't do anything, people will send messages to everyone and so on. Like it become like there will be network congestion at the end. And there is encrypted payload, which is basically just encrypted message. So how the proof of work works? So basically, it prevents a node from spamming the network. The concept is the formula here is shown as here. So it's defined as average number of iterations required to find the best bit. So this the number of leading zero bits in the hash dividing by message size and TTL. So as you can see, proof of work is inversely proportional to the size and TTL. So as a message is small, it requires higher proof of work. They made it specifically in that way because this whisper is suitable for sending small data chunks, not large amount of data. And this is a basic mechanism of calculating the hash. So every node will calculate the hash like this. So and there should be the leading zeros should be, there should be leading zeros, like as shown in here. Like let's say if in requirements it says the first first 3 bits should be 0, you have to find it by calculating the hash, and it requires some work basically. So because you don't know, it's like a random. So every node should calculate it, and yeah. So after creating the message, so nodes should be repeatedly incremented as shown is here, and the hash should be calculated with some leading zeros, and it requires some work for node. But as you can see here, like for instance here it's only 3 zeros, and in Bitcoin or in other systems the number of zeros is much like higher, so like maybe 10 or 15 first bits should be 0. It requires much more proof of work, but here it's like more simple to just prove that you aren't spamming the network. And the priorities of the message is decided on the following factors. So higher proof of work, higher priority. So it basically means that if the size of the message and TTL is smaller, and you calculated the best bit, then you have higher proof of work, and your message priority will be higher. And so it means basically if you send large data chunk, the proof of work will be smaller, and your message might not be delivered. And also similarly lower the TTL, the higher the priority. And message with proof of work below a specified threshold is rejected. So yeah, the more work, the faster your message will be propagate through the network. And let's talk about the encryption and decryption. So it could be in Whisper, it could be performed either symmetrically or asymmetrically, and messages could be decrypted by anyone who possesses the corresponding key. So as it spreads the network, everyone should decrypt the messages as they receive it. But yeah, so a node, let's say a node must try every key it holds before it can determine whether a piece of message is sent to its user. So basically, nodes don't know, like they receive the message and they don't know like this message is for them or not. They have to use every key they have and decrypt this message. And it requires like plenty of time and power. So decryption is expensive here. So they implemented topic. Topic basically determines whether it's worth to decrypt a message or not. So basically every node sets a filter. It's a kind of filter. So what kind of topics they want to receive. So when you want to send your message, you look the topics of the nodes and send only to specific nodes. So it's kind of reduces latency and the processor load. But it says like use of topic field might reduce darkness, but yeah, but there is only small influence, I think. Still, you don't know like if this messages was sent to specific node or not. It's still like you cannot find it. So weaknesses, what kind of weaknesses Whisper has? It's pretty similar to Tor. So there is like performance issue, and it isn't good for real-time communication and sending large data chunks. So as I told before, so it's more like useful for small data chunks. Yeah.
Is there some sort of limit on the size of the network?
Size of the network?
Yeah, how many participants can be active at the same time?
No.
Okay.
No, it's like a blockchain. So there could be many nodes and so on. It's much better, I think, if the node there are many nodes, as in the Tor. Yeah. And yeah, we finished. Yeah. So I thought we will discuss some properties, use cases, barriers to wider adoption for these two protocols, and we will write down some requirements for such systems. So let's do it. I will. Yep.
I'm sorry. Did he say that it scales and it's proportional? Like if it scales a lot of people join their network.
Yeah.
Isn't it bad for the network? Like there will be a lot of. You have to process a lot more data because we receive a lot, and you have to check every package. I think it's bigger, so.
Yeah, but I told like for anonymity it's better.
Oh, okay.
For scalability it would be problematic.
It's not very scalable.
Yeah.
Technically.
Yeah.
Maybe,
but
maybe if you divide into smaller.
Yeah.
Nodes, in smaller networks.
The division here is, as I told, it's like kind of topics. So every node will have some topic. So that is used for like for scalability, I think. But otherwise, it's similar to blockchain. So it has some scalability problems as a blockchain, like typical Bitcoin and so on. Yeah.
If the number of users will increase, let's say it will become 100 million people.
Yeah.
With 100 million devices, do you think it will be more faster?
No, I don't think, because as he told, like every node have to decrypt every message. Yeah. So like if there is a million users, they will send messages, and every node have to decrypt so many messages, and it's expensive in terms of performance. So I think in that case they need to implement some other stuff to make it more scalable. Like these topics isn't enough, will not be enough.
And what if the hardware will, like performance will be like increased like 10 times or 100 times? I don't know, like Intel creates some kind of like, the super fast processor or video card or something.
Yeah.
Do you think it may be like faster? No? How optimistic are you about it?
So basically, there is like quantum processors. Yeah. But if this kind of processors will come to reality, our like cryptographic mechanisms will also not work in that case. So it will be another problem. So yeah. And one thing is that this proof of work, you can control it, like the leading zeros, like if it's only 3 bits or 4 bits, and you can control the processor load. By in Bitcoin, for instance, it's in 10 minutes. So miners could calculate the hash in 10 minutes, but they also fix it when there are many miners. They fix it. I mean, they increase it, for instance, and they decrease it so it's controllable automatically by the system. So yeah, but quantum computing is. I have read some articles about like IBM and so on are developing this, but still they aren't very efficient, like not practical still. So I think it's quite a long time to come here. So if it comes, probably this public key cryptography and everything will be broken in that case. Could be broken, yeah. So yeah, so we will have more problems than just proof of work and so on, like, because our security is based on these cryptographic techniques. Yeah.
You mean the hackers can brute force the password? Or
yeah, because it will be, you have more computational power basically. Yeah. So yeah, I'll try to change this one. So yeah. So together, let's write down some barriers to wider adoption for such kind of protocols? Does it seem? Okay. Yeah. So any ideas?
Speed.
Speed, low
It's
speed.
not fast, yeah.
So yeah. So yeah, currently they have low speed, low performance. What else?
Low capacity for average capacity
Um,
in terms of
processor load and so on. Yeah. For mobile also it could be. Yeah. What else?
Really good scalability.
Yeah, for overall network. This is more true for Whisper, but for Tor, what do you think?
Yeah, I was thinking more about this.
Yeah, Whisper, yeah. For like decentralized one. For Tor, I think if you have more nodes, it's more like it's okay, I think. Mm,
But if you want to solve the problem, you use topics.
yeah.
But if you start using topics, you kind of lose a bit of the anonymity.
Yeah.
Yes. Maybe you should you start using more specific topics, so something really specific, like something illegal, and you can get track like that. You said for our group. No, actually, no.
No, in one case you are right because so it's more like also the scalability issue. So to solve the scalability, they use topics and so on, but it isn't solving the problem fully. Yeah, so yeah, you are right in that case. So I wrote some also like if they are maybe for specifically for Whisper, it's like Young protocol, and it's proof of concept. So it's like it also kind of users don't want to use it because of that, maybe because it isn't proven yet. Anything? Which could be barriers to wider adoption? And maybe one case could be like usability, for instance, because yeah, typical user cannot use it. I mean, it's still hard, and they don't understand the privacy. I mean, what these tools bring them. So that could be the case also. Usability generally. Have to use the right one. Okay. So let's write down some use cases then. I think we have gone through the use cases for this kind of protocols, but generally to repeat it.
I think the private companies can do it for the transparency. I don't know, for privacy. Because I have recently talked with American one guy, software engineer. They're scared of messaging targets on sensitive data because if somebody finds it out and spreads it on social media, the stock price of the company will decrease or increase if it's really sensitive to that kind of message.
Yeah, so they want to use some
Something
privacy-preserving communication tool, yeah? Not just the public ones and so on. Yeah, so it's like anonymous. Anonymous privacy-preserving communication. What else it could be? So this is the most use case probably, but so just for typical case, yeah, I mean, if you want to privately browse, like it also like internet browsing, or just like safe internet browsing. It's for Tor basically. They have Tor browser, and they have also Tor Messenger. But in case of Whisper, it's just Messenger.
Can I broadcast for everyone, like with some key that everybody has?
In case of Whisper or what?
I want to broadcast for everybody, but I don't know. I don't want them to know who I am.
Yeah.
But I want to say a message to everybody who visited the network. The government of that country is doing that, but I don't want to broadcast for one specific person. I want to broadcast for everybody.
Like a coronavirus, let's say. He wants to spread that coronavirus really serious problem, guys. Be careful and don't panic. Be on panic or something.
Yeah, but in that case, you cannot preserve your privacy basically, because every node should have then the key to decrypt your message, and everyone will know that you are the sender basically. Yeah. The mechanism works like sending to everyone, but you are trying to send to only one of them. So other people will not know that. Yeah.
They cannot decrypt at all.
Everyone?
Yeah.
Yeah, but because the mechanism works like you have to first handshake with key exchange. Yeah, so in the second case, you have to share your key or to everyone if you use symmetric key encryption. So it basically everyone will know probably that you are. Yeah.
Can you just technically not have a message be decrypted? If he wants to share it with everyone.
Yeah. Just sharing with everyone and without message encryption.
But that was the point, wasn't it? Yeah. So we don't need to encrypt it at all.
Yeah, it could be, of course, but specifically for these ones, it will not work. But you can implement such kind of messenger that you can send to everyone and also at the same time be anonymous. Yeah. But I think it's I don't know if it's feasible, but no, yeah, not sure. Because currently we have IP addresses and so on. So if you want to hide that, you have to use encryption. And if you use encryption, that recipient should be able to decrypt it or some other node in the middle. Yeah, so. or in case of Tor, maybe you can use that, like send to multiple users, probably, because it has 3 steps, like first node, second node, third node. And in the third node, it just sends the data chunks without encryption to the recipient. So in this case, you can probably send to the multiple recipients. So this is encrypted 3 times, this is 2 times, this is not encrypted only, yeah, at the last stage. So basically, but this node will know like the recipient, but they will not know the sender here. Yeah. So in Tor, you have some choice for that. But in Whisper, I don't know. Yeah. So other use cases, any ideas?
Less tracking on the web. Like if you don't want targeted advertisement.
Yeah. So you mean less tracking?
Yeah, less tracking.
Yeah. I think it's here, like safe browsing. And also, I think it could be used for illegal activities. Yeah. It's kind of.
Messenger. How can I check it? Like, I don't know, maybe there was some hacking code in the browser they added or something.
I think you cannot have 100% guarantee, but typically these tools are open source, like.
Yeah.
So I mean, everything is publicly available.
Yeah. Is there any responsible person for this, like non-profit organization or someone who is developing?
I'm not sure typically for these messengers how they handle the governance, but for typical blockchain applications, for instance, some Bitcoin or Ethereum, they have like non-profit organizations that handles the governance, and they are like developers and so on. And all documentation is available open source. It's open source and so on. So but yeah, generally the typical user will not be able to check it, the code and so on. It's impossible. But still, there are many people who can do that. So I think like if it's open source, it gives you some guarantees that it's more like transparent and so on, like it's working properly. It's much better than having some private company with private database and private stuff. In that case, it's really unknown. You don't know anything.
And about the open source, for example, it's open source. Can I directly go and download that open source code and use it? Or like it's just the interface of the code? Like it's just the code description and all this, that's it?
You can contribute to those.
Oh.
Yeah.
And I can use it at the same time, right? With that
Yeah.
code. Okay.
Yeah. Yeah. It's like an Android also. For instance, yeah.
But Android is related to the Google.
No, the open source one, licensed one, they don't handle it. But other like additions, for instance, there was a case with China, Huawei.
Yeah.
So they could, like Huawei still can use open source Android platform, I mean the basic ones. But after that, they cannot use like Google Maps or Play Market and so on, like additional tools.
Okay.
You know, so.
How was it controlled? Google suspended that?
Yeah, like U.S. government
has access to that operating system.
No, U.S. government just made some sanction,
Yeah.
and Google obeyed it, and like it canceled all connection with Huawei.
Yeah.
So Huawei couldn't use the tools offered by Google, but they can still use Android. It's a basic, but that Android is really basic, even though it's open source. So because after that, on the top of that, many stuff was developed as the time passes. So, but I don't know how this case was solved. I mean, I read it like it was an issue in like 6 months ago, but currently maybe they just opened it. It's like politics, so you don't know how they how they do it. Yeah, so I think it's working. Yeah, it's working. So let's have a break. Yeah, let's have a break for 10 minutes maybe. Then we will continue with requirements and authentication systems. Yeah.
Did you have a security background before joining getting into these topics for specialization?
No, I just had some computer science, but security I didn't have.
Okay. Was that a big challenge for you about the security option?
Yeah, at the first, yeah, probably because I had to take some cryptographic courses. So it was tough. Yeah, you are interested in that?
No, actually not. I was just curious about how hard is this conversion, or if you had to have a strong background to get into this topic.
Yeah, but if you are really interested in this topic, you can do that.
I'm going more into the data science.
Data science, yeah.
But I think it's interesting. Cryptocurrency, I think it's something that will won't change anything. So I think it.
So you believe it has some future?
Yeah, I believe. Don't you?
Sure.
Well, you are investing so much time into this.
Yeah, sure.
But, yeah, I really feel like it's doing something that we will stick on.
Yeah.
Unless they find something crazy to break everything.
Yeah, but like there are plenty of really
Alternatives, or
no, I mean there are many people who are working in this space, so I think it will get evolved for better. I mean that for alternatives, of course they could be, but we don't know. But for data science, it's also kind of it has for sure it has future because we have plenty of data now, and we need data scientists for sure. But you need to be data scientist. You need to have knowledge of statistics also, and that part is also not easy stuff.
yeah,
The hardest one is you can of course code it like just using
the tools and
tools and so on, but if you want to deeply understand it, you have to learn some statistics.
yeah. First I started doing in the same time statistics and computer science, but it was impossible, so I gave up about statistics and started doing only computer science.
Yeah, because it's really hard, but you should have some background. That's enough. Because I have taken some courses. I was interested in data science before when I was studying, and I have taken some courses like deep learning, reinforcement learning, and some statistical courses, and it was full of math.
Yeah.
But cryptography is it's not easy stuff.
Okay.
Yeah. Hope it's working. So have you organized some meetings for your project or? Yeah? Yeah, so. So the requirements for privacy-preserving communication tools, communication systems. So basically, the first one, maybe we want anonymity for both sender and receiver. What kind of other requirements we need to implement or develop such kind of systems here? So For proof of work, it's just one mechanism, so it could be developed in other way. But for hardware, it could be also the case like you need some high performance hardware, probably, yeah.
And is your account linked to that hardware? For example, you have an hardware, and do you use it as your identity or something?
No. It's just to do some work, like that's all. So, what else? Yeah. Yeah, you're right. So it's like distributed system. So routing mechanism, which is efficient, yeah. You can consider broadly, like for like as a system, let's say, not just a protocol. I mean, just so it could be, for instance, we mentioned scalability. It should be scalable. That's
Should be open source.
yeah. Yeah, we can like it should be. Yeah. It should be open source, free. Yeah, for sure. So,
In order to obtain the name of Unity and to facilitate so like if I somehow get your phone, then I can't do the messages because they're not scalable network.
you mean like distributed storage?
Because otherwise I think definitely need messages.
Yeah, I agree. Yeah, because it should be better if you have distributed storage, so you will so it will not be single point of failure. Yeah, not centralized. What else we mentioned, like in like weaknesses and in wider adoption case, so we can write down them also. So we told like there could be some attacks, yeah, like yeah, civil attacks or some other attacks. So it should have strong adversary model. So the system should withstand some attacks performed by adversary. And yeah, but for this kind of stuff, it would be harder because we want to preserve the privacy and anonymity. So authentication, identification could be, in some use cases, it could be problematic. I mean, not necessary. Yeah. But for some use cases, you might need some sort of identification also. But generally speaking, let's talk about more like general. So so for users, it should be usability. Right? For last one, let's write usability. so it should be like more understandable for typical users and easy to use. Yeah. Do you have any other options? For your projects, I think you will also have to some kind of write down some requirements, yeah, technical specifications. If you don't have anything, we can move to the next topic. So I will talk about authentication systems. And so we will start more traditional ones and then move to more the latest ones, latest improvements and developments in this space. So there are three main types of authentication available today. The first one is something you know, like a password, PIN, or a code. So like password login. Something you have, like token or some private key or something like that. Something you are, so which is biometrics, like fingerprints, voice ID, or some face recognition system. So yeah, as an example. And we will go through the second one and third one. The first one is the typical traditional one, so it's more like just login with password, and there could be some two-factor identification. Yeah. Mm-hmm. Yeah. Yeah, I was also thinking about the private key option. Yeah. It could be also the case, yeah. So the first one and second one could merge. But you know, for if we think like in terms of usability, people cannot remember that. So yeah. So have anyone heard about OpenID or OAuth? Yeah. This is our like protocols for authentication and authorization. Can anyone say what is authentication and what is authorization and the difference? Yeah. Yeah. OAuth 2. They used by Facebook. Yeah, you're right. So so OpenID protocol is for authentication and OAuth is for authorization. So basically, so the protocol enables websites or applications to grant access. It's like a Google sign-in or Facebook sign-in. It's typical examples. And OAuth protocol, it's like they give you access to some protected resources from a web service. So you will be authorized to perform some actions. Example, let's say an application TweetPic. So we have many applications like for Instagram, for Twitter, like third-party applications. they act on your behalf and access your information from Twitter or some Instagram, for instance. So in simple terms, the OpenID was first proposed in 2006, and it's about verifying person's identity, like who are you. OAuth was implemented, developed in 2010, and it's about accessing person's stuff, authorization. And OpenID Connect, it's a merge of like a combination of these two, so it does both. And so basically, Facebook and other identity providers use OpenID Connect now. So it provides both authentication and authorization. For OpenID Connect, it's JSON based. So it's a second case. So it gives you some token, and you can use that token for some time. It has some time to live. So for OpenID Connect, you can receive from authorization server two things: ID token and access token. So basically, ID token is for authentication, and it's shown as here. So it shows the issuer, subject, and some other metadata. And access token is for authorization, so what you can perform, what kind of actions. And single sign-on is it's a general name for this kind of approach. So OpenID Connect is a single sign-on basically, and it has different implementations. For instance, Facebook Connect, SAML, it's for enterprises generally. So, and Microsoft account. So it's like federated identity. For using, you will have one identity from one identity provider, and you can use it in multiple websites. Let's talk about the pros and cons. So the pros are like it's open standard, and it works with native mobile applications. And here it says with IoT devices, but I'm not sure. Did they implement it already? And it includes mechanism for user identity, data transfer, and storage consent. And it relies on HTTPs for encryption. And as I mentioned, it uses JSON web tokens to store and verify identity data. But there are some drawbacks, and these are the first one. Even though here you will have federated identity, but still, if for instance Facebook collapses, you will lose your identity, and you will not be able to access other websites which you used to before. So it's like more like still some kind of centralization. Second is it's still less common solution in the market. I read that only 5% of websites use this technology, so it's very less common still. And here the third one, it's HTTPs. They use HTTPs, and it's only layer of encryption. So like you have less security. I mean, they don't have external encryption techniques and so on to make it more privacy preserving and so on. So for the second case, why do you think these kind of technologies are less common? Have you used this kind of technologies before? I think so, because we generally, for well-known websites, we have this technology. So you can log in with your Facebook, your Gmail. You can choose what to log in, and for any new website also there is an option to log in with your bank ID and mini bank and so on. Like it's also OpenID Connect technology. The provider is Signicat. It's a company, and they provide this resources for NTNU and other educational institutions. I don't have exact answer why they many websites don't use this. Probably one case could be.
Nobody knows. I didn't know it.
Yeah.
I know the Google, I know the Facebook. That's why I use their login system.
What's you mean? It means that you are using it basically.
Ah, yeah.
But you didn't know that what is behind in this technology or something like that. So like, yeah, probably some small websites don't know this technology, or it's harder for them to implement it still. Yeah.
I think you have to be approved also, not you? On Facebook, I think they can. I'm pretty sure if you are abusing the data or something like that, they can cancel.
Yeah.
Your permission.
Yeah.
So you have to. Maybe there's a lot of bureaucracy behind it.
Yeah. That could be the option. Yeah. I mean the case, because I don't think Facebook will give their login options to any website. Yeah. So yeah. It's also yeah. Any other? But that's a good option. Yeah. I mean yeah. So I think like it's open standard and it's like non-profit. So there is no push behind it, like no one is pushing, and some private companies don't want to share anything. They want to hold their own databases of users, probably, and so on. So maybe that's the case. Or it could be like different reasons.
This whole single sign-on thing requires all these big actors to cooperate together, which they may be reluctant, which may be difficult.
Yeah, the cooperation case. I mean, it's like federated identity, so like some identity providers should collide, but it's harder. You mean, yeah, the cooperation. Yeah. Yeah. For instance, in case of banks, they for sure don't want to share their user base with other bank and so on. So yeah. So basically, currently we have this kind of identity proven methods. I mean, this model. So we will have holder. It's a typical user, and if he wants to verify his identity, he needs some document from issuer. Let's say some bank. And when he enrolls, I mean, he wants to use the service provided by verifier. Verifier is like kind of service provider. So here it could be employer, website, or anything. And for verification, they rely on identity provider, some kind of Facebook or Signicat, which provides bank ID, for instance, or some other third party. So typically, currently we have such system. So, and in this system, the data used for authentication usually is stored in centralized databases, and generally users lack control over their data, so they don't have much control. And these identity providers like Google, Facebook, and Signicat, I mean, they have more and more data. They are collecting so many data. They can track who is login information. They can have some authentication data, metadata, and it's like they are getting richer and rich every time. So, and we have here self-sovereign identity system ecosystem, which is proposed recently by some researchers and some research groups. So here the information is no longer centralized as it relies on some public blockchain, and they also use new technique, decentralized identifiers, which I talked before, like a couple of lectures ago. It's a new type of identifier. It's like a URL or something, and it connects to DID document, which stores metadata. And this DID document is stored in some identity hubs, and identity hubs is also user controlled. Basically, it could be some distributed storage mechanism or some, even though some some Dropbox or anything that user controls. And so as you can see, here we don't have identity provider at all in this ecosystem. So we have only holder, issuer, and verifier, and verification is done through blockchain. So it synchronizes the data, and issuer and verifier can connect to this. So they have access to the blockchain, and they can verify the credentials from holder. And also users, yeah, as I mentioned, users have the liberty to manage their identity data on their mobile device as a wallet, some kind of, or in some cloud repositories. So the main difference, so there is no identity provider, some third party. Users have more control, and yeah, and there is no longer centralized databases and so on. So how this mechanism technically work? I will try to go through it, but yeah, let's try it. So every DID, it's like it has some kind of sort of this kind of syntax, and it specifies who you are, basically. I mean, what you have maybe. And it's connected to DID document, which stores some metadata about you and some proof mechanisms. And here is the DID document, the basic one. It's like, yeah, it's in JSON format, and it has some authentication mechanisms like public key, your digital signatures, and so on. And when when this issuer will and verifier need to resolve your DID to DID documents, basically, and it's done through blockchain. So this is one example. So for instance, here you want to, through your web browser, you want to connect to some web page. And in that case, web page will send you some challenge, in DDoS challenge, and it will display some QR code. And you can scan this QR code with your mobile app, and in your mobile app, you will have your identity wallet, like self-sovereign identity wallet. And through that mechanism, you'll verify that you are owning this DID, like you will verify your unique identifier. And you will send your response, DDoS response, to the web server again. As a transport mechanism, you can use HTTP post and so on, anything else. And through that, you will verify. And the resolution, I mean, the DID resolution will happen through the blockchain and so on. Yeah, but it could be different. So there are some implementations of this new type of system, like self-sovereign systems, and I want to go through two of them. One is, interestingly, uses the OpenID Connect that I mentioned before. So in OpenID, it's a protocol, open standard, and they have one mechanism called self-issued OpenID Connect. It means that everyone can verify its identity by itself. So there is no need to rely on identity provider, actually. So there is some mechanism which you could use as like self-issued credential or self-issued self-verification. But currently nobody uses it because for typical user, it's hard to understand what is a protocol. So I mean, just typical users don't use it. They just use some identity providers like Facebook and Google. But these researchers tried to implement this self-issued OpenID Connect with self-sovereign identity mechanisms like DIDs, and tried to implement it in that case. So as you can see, the protocol, in this protocol, so it's this self-issued DID is a draft specification being developed by Decentralized Identity Foundation. It's a non-profit organization which aims to develop some new implementations for identity verification systems. So they typically use DID, they use blockchains, some distributed storage mechanisms, and so on. So they want to give more control to users. So they are implementing new methods. And this one is one of the protocols. And so it leverages identity wallet on the mobile device. So as you can see, when a user, here user agent is just typical browser. When user opens agent and enters URL, it will be, the HTTP request will be sent to service provider, and service provider will connect to COP server, so like self-issued OpenID. And here the protocol works. So verification and validation is made by this COP server, and it will be done by your identity wallet. So at the end, you will verify your identity through your identity wallet. So there is still no third-party identity provider. You are just verifying using your like you are verifying that you are owner of this DID and so on. So yeah. The second protocol is Horcrux Protocol. I found this article in publication. So it's like Horcrux is, they have taken this name from Harry Potter, yeah, and they named it their protocol. So it's distributed identity authentication protocol, and it's a biometric authentication, and it relies on two standards. The first one, IEEE Biometric Open Protocol standard, and second is decentralized identifiers, DIDs by W3C. So both of these protocols are open standards, and they combined these standards and made one protocol which they named Horcrux. So this biometric open protocol is so it's a distributed biometric storage approach. So and so the biometric enrolled data like fingerprint, voice, facial features are cryptographically protected into two shares or multiple shares using secret sharing scheme, visual cryptography, and so the shares are stored distributedly. Like one share is stored in your mobile device, second one is stored in Bob's server, so in remote server. So such that the biometric data isn't kept in a single point to compromise. So basically, can you see that? Yeah. So we currently have service-centric model. In that model, that biometric data is stored in the server side, and verification and everything will happen in the server side. Or another case, we have mobile-centric model. In that model, the biometric data usually stored in your mobile, some secure storage. But this Bob's distributed model is combines this, and they implemented it like you can store your biometric data, like you can divide it to two shares, for instance, and you will send one to server, one is in your mobile device. So in that case, if if you lose your mobile device, or if someone will get your mobile device, he will still not be able to use your, get your biometric templates. Or in other case, if someone will hack the server and get your biometric shares, it will be only partially, so it will be useless. So distribution is good, and in that case, the Bob server is this thing. And so this protocol, here it's enrollment phase, how users are enrolled. So first, user using his mobile device, he collects his initial biometric vector. So typically you will just press the biometrics key, and so it will, the mobile device will collect your initial biometric vector. And the mobile device will encrypt this IBV into 2 shares. And 1 share will be stored locally, half of them. And second share with enrollment private key will be sent to the Bob server. And this server will create DID for you and create DID docs. And in these DID documents will contain the issuer signature, enrollment signature, and encrypted share, the second part. So yeah. So the second share will be stored in DID documents. So you distributed your biometrics template basically in enrollment phase, and attached your biometrics to DIDs, your identifier. And as you can see, there is nothing is stored in blockchain here. No biometrics is stored in blockchain. So here, the remote, how authentication happens. So there are 2 implementations for Horcrux protocol. One is remote authentication mode. Second is local authentication mode. In remote authentication mode, the typical saying is like, as you can see here, verification will happen in the server side. So matching is done in the server side. And there is no need for third-party identity providers here. But in case of local authentication, the matching will happen in the mobile device. So you will get your second share from your server and match the biometrics in your mobile. But here in remote case, it's done in the server side. And after the combining shares and performing match, if match successes, it will purge share 1 and share 2 and associated keys. So it will delete everything, the server. So yeah. So basically, they try to implement some distributed storage for biometrics with this protocol, and they try to connect biometric authentication with DIDs, so to make it workable. But it's only just a publication, so there is no proof of concept and so on. And basically, they just rely in 2 standards, and there is no implementation yet, so we don't know exactly how it works, and we cannot analyze it if it works and so on. And there could be some attacks also, so it needs to be evaluated later. Yeah, but I just wanted to show you some new authentication models proposed by researchers and so on, to get some kind of feeling what's happening. Yeah, so there is some references. If you are interested, you can read about this. I wrote everything here. So what else I want to talk? Yeah, I think. Any questions? If you don't have any questions, I have one question. So next week, you asked me, so you have a project presentation on 23rd, on 23rd of March, and next week it's 16th of March, the class time. So last time we agreed that the second part of class you will have some sort of discussion and try to cooperate with other group. So you have 2 groups, technical specification and some requirement specification group. So you could have some sort of discussion and share what you have done to other group and discuss, because you'll swap after that, you know that, yeah? So, and you can also prepare for presentation for the other week. So I think it will be best to devote the second part of the lecture to this kind of discussion, but I wanted to discuss in what format we can do that. Because just discussion, it will be like mess, maybe. How are we gonna do it to be more effective, efficient? Any ideas?
First off, if we're going to do this next time, then we are going to need to be more people on this. We need more representation of the groups. So everybody needs to know in advance that we're going to have this meeting.
Yeah. Then I can make announcement on Discord, and you can also communicate to your group members. So everyone should participate in that lecture. It will be best for you. And probably you can prepare some slides, like 2-3 slides, and prepare some kind of draft presentation, each group. So you can just present your ideas to the second group, and second group will also present. So it will be practice for the presentation and so on, like. And then you can discuss like how you can proceed and so on. It will be more structured. What do you think?
At this point, there will be a very simple presentation.
Yeah, it's just simple. Yeah, yeah. Just what you have done. You can just list everything and so on, like, or any information you want to share. So I think it will be good for your like next time presentation in the next week. Yeah, yeah. So we agreed on that. And I think after the next week, Mariusz will come, so he will take the presentation from you himself. So I will not take. So the next week I will handle the lecture, but after that he will come back probably. Yeah, not probably. He will come back. So he will be present in the presentation week. So yeah. So I will make announcement on Discord, but I ask you to also to chat with your members, and so everyone should come. And if you can have meetings this week, it would be best for you, because yeah. So I think yeah, each week you have to have some meeting, because just lecture time isn't enough. Okay, so I need to stop the streaming.